Hi all, I am Roland and I am the extreme digital nomad. I write code, always and everywhere. Welcome to this episode of the Augmented Software Engineering Podcast. Please read the blog post that is in the description to understand what this is all about. In the last episode, we generated some code to implement a Huffman coding. In this episode, we will review the code to make sure that it is of good quality. To speed up the review, we will first just go through the code and add a couple of to-dos. We will then work through the to-dos one by one to address the issues. I guess we will address some of the issues with the help of our trusted AI assistant and some of them manually. Let's get started. The good news is the code looks very good. It is clearly structured and very readable. And it uses the new Scala 3 syntax where you can create blocks of code not by putting them into curly brackets, but by indenting them. Let's try to make the code even better. First, I think we need some documentation. That should be easy to generate. Then we need a logger and some logging. All production code needs to be observable one way or another. To make our live easier, I would also suggest to add another function that takes a string and returns the list of codes. Now comes the first big issue. When you think about the concept of Huffman codes, then the codes should not depend on the order of the frequencies. Means it feels more natural and right to calculate the Huffman codes from a set of frequencies and also return a set of codes. Let's fix this. Much less severe is the question, if you want to use an if statement or use pattern matching. I personally like pattern matching better. The next one is a little bit more severe again. There is a well-documented edge case when you have more than two nodes with the same frequency, because then it depends on how the sorting of the list is implemented. To make the sorting predictable, you need to sort by frequency and symbol. The symbol becomes the tiebreaker for all nodes with the same frequencies. Last but not least, we can prepend or append the zeros and ones to the code string when we build the codes. Let's make sure we find and use the correct implementation here. Now let's take a quick look at the tests. First things first, the test for the single node is wrong, because for a single node the Huffman code is the empty string. Let's then add at least two more tests. One for a list of elements with the same frequencies, and one for the test string from the Wikipedia page. That's it. Overall, not too bad. Let's now start to fix these issues. The first issue we want to fix is that the test case for a single element is not correct. Let's fix it. The Huffman code for a single element is an empty string. To help the AI, we will also open the file that implements the Huffman coding. All open files become automatically part of the context. We then ask to fix the code. Great. That looks like a good fix. Let's test it. Okay, I was not specific enough. This is a new session and it lacks context. Means I need to tell the AI to use mil as the build tool. While we are waiting for all tests to run, I just want to emphasize that it is important that you own the tests and that you start fixing problems by writing good tests first and only then ask the AI to help with fixing the implementation. That way you will always stay in control of what the code is actually doing. And great! This compiles and all tests are passing. That's it for today. There is good news. The initial code that we got is of good quality and is already very idiomatic. But there are also a couple of issues that we need to address to improve the quality of the code even more. And we obviously need to add more tests. Let's tackle these issues in the next couple of episodes. See you next time, and do not forget to like and subscribe.